Exercise 7.2, Problem 11, Discussion. Let's read the problem. A boy is standing at some distance from 30-meter tall building and his eye level from the ground is 1.5 meters. The angle of elevation from his eyes to the top of the building increases from 30 degrees to 60 degrees as he walks towards the building. Find the distance he walked towards the building. Okay, so basically the height of the building is 30 meters and his eye level, that is on this, we're standing vertically in the ground, so his eye level is about 1.5 meters. 1.5 meters will be about 5.5 feet approximately, right? Now, which is the height of the normal person. And his angle of elevation to the top of the building was 30 degrees. And then he walks towards the building. And the angle of elevation increases to 60 degrees. And we are asked to find the distance he walked. It's exactly like the previous problem. Only thing is that there we took that the eye level as a ground level there. When they don't specify anything, eye level will be the ground level. Right? And here they have specified the eye level is 1.5 meters from the ground. That's the only difference. Okay? So let's draw a simple diagram. EG is the building, and this is a person standing here, and this is his eye level, which is 1.5 meters. From here, he is seeing the top of the building, so this is his line of vision or line of sight, whatever you call. Okay, and this is his eye level. And what is this? This is the angle of elevation. He is looking up, and the angle between the line of vision and the eye level is the angle of elevation, that is 30 degrees. Right, now he walks from A to C. So this is where his eyes are, and he looks again at the top of the building, and the angle of elevation is 60 degrees. This is the line of vision, and this is the eye level or the horizontal line at the eye. Okay, through the eye. So this is your new angle of elevation, and we are asked to calculate the distance he moved, that is AC. Okay, and we know this is 1.5 meters, so this is also 1.5 meters. The total height is 30 meters. So if you take away 1.5 meters, you will get this as 28.5 meters. So if you look at this, we need to calculate this, and we need to calculate this, and you subtract this from this whole, you will get the distance he has moved. Okay, so basically we need to calculate adjacent side. So what is the relationship between this angle, this known side, and this unknown side? That is tan theta. So tan 60 is opposite by adjacent. So when you consider this triangle, using tan 60, you will be able to calculate this distance. Similarly, in this triangle, that is GBF, this is known, this angle is known, and we need to calculate BF. The relationship between this unknown, so this known and the unknown, and this angle is tan theta. Tan 30 is opposite by adjacent. So from that you will be able to calculate BF. Once we know the total distance and this distance, subtracting this from the total, you will get this distance, which is the distance the boy has moved towards the building. Okay. So please keep this in mind. This is how this problem is going to be solved. Let's list out what is given in the problem. Height of the building is given 30 meters. The eye level is given 1.5 meters, right? Angle of elevation is given 30 degrees and 60 degrees. We are asked to calculate the distance the boy walks towards the building. So he is here initially. He walks towards the building, and this is his final position. So we are asked to calculate AC, right? Okay. And as I was explaining, the relationship is tan theta, opposite by hypotenuse, because this is known and this is unknown, and the relationship between this known and the unknown, and this angle is tan. So tan theta, tan 30 gives us the value of BF. Similarly, tan 60 will help us to find DF. Okay, so in this problem, we'll be using the trigonometric ratio of tan, that is tan theta. Okay, right. The first step, as usual, draw a simple diagram, label and mark the diagram with the given values. That's what we have done. This is the eye level, and this is the total height of the building. And I've removed this 1.5 and taken this to be the height of the building above eye level, that is 28.5 meters. These are the two angle of elevations. Calculate the height of the building above the eye level. As I said, that's what I did first step. So this whole thing is 30. So take away 1.5 meters, which is the height of the eye level. So the building will be 28.5 meters. That is 30 minus 1.5, 28.5 meters above the eye level. Next, in the triangle BFG, okay, substitute the value of theta, which is 30 degrees, height of the building, which is 28.5 meters above the ground level. In the formula, tan theta equal to opposite by adjacent, that is equal to FG by FG is 28.5 and FB. So what will happen? Tan 30 will be equal to FG is 28.5 divided by BF. So this is known, this is known, this is only unknown. We will be able to calculate BF. Okay. Next, do the same for the triangle DFG. Okay. And the same thing, tan 60 will be opposite by adjacent, that is FG by DF. So this is known and this is known, right? So from that, this can be calculated, right? Now, you have found BF and you have got DF. So subtract DF from BF, you will get this distance, which is the required distance. Okay. So what I suggest is pause the video here and try to do this problem on your own, and on completion please come back and check your working against our solution. The solution. So let AB and EG represent the boy in the building. This is AB the boy and EG is the building. Okay. Next, angle of elevation is GBF. For when he was here, he was looking at the top of the building. So this is his line of vision and this is the horizontal level line to his eye, or this is his eye level. And angle of elevation is looking up between the line of vision and the eye level. So this is 30 degrees. Then he moves towards the building, it becomes 60 degrees, right? Now, we know the height of the building is 30 meters and the boy's eye level is 1.5 meter. So this is 1.5 meter. This is also 1.5 meters because these two lines are parallel, right? Now, 30 minus 1.5 is 28.5. So first calculate the height of the building above his eye level. This is his eye level, right? So above his eye level is 30 minus 1.5, that is 28.5. Now, in the triangle GBF, tan 30 is FG by BF. Is that right? Tan 30 is opposite FG divided by adjacent, that is BF. And what is FG? Is 28.5 and BF we want to calculate. What is tan 30? Is 1 by root 3. Cross multiply, BF will be equal to 28.5 into root 3. Okay, now we got the value of BF. Do the same thing in the triangle DFG, that is tan 60. Okay, tan 60 is FG divided by DF, that is 28.5. Tan 60 is root 3. FG is 28.5 divided by DF, or DF will be 28.5 by root 3. So that is into root 3 by root 3. That is, this will become 3. 28.5 root 3 by 3. So that will be 9.5 into root 3. Okay. So we got this as 9.5 root 3. So this is 28.5 into root 3. And this distance DF is 9.5 into root 3. So we know BF equal to BD plus DF. BF will be equal to BD plus DF. Right? Now, okay, so now substitute that value. So 28, this is BF is 28.5 root 3. BD is, that's what we want to calculate, and DF is 9.5 root 3. Bring BD one side. BD will be equal to 28.5 root 3 minus 9.5 root 3. So this will be 28.5 minus 9.5, right? That is 19 root 3. Am I right? So this distance is 19 into root 3. We don't need to substitute root 3 as 1.732 and calculate it. Leave it there as it is. Okay. So the boy has moved a distance of 19 root 3 meters towards the building. Okay, and that's when the angle of elevation increases from 30 degrees to 60 degrees. Right, so it's basically you have to take this triangle into consideration and then this triangle into consideration. Use tan theta, you will be able to get the two values, two distances, and subtract this distance from the total distance. You will be able to get the distance moved by the boy. Okay, so I hope I made it clear. Please try to do this problem one more time on your own. It will become very clear. Thanks for watching this video.